going? It's Mr. Murray coming to you with a Do Now for Course 2 Honors for Tuesday, June 16th, 2020. All right, so here's our situation. You and your team decide to take a trip to Friendly Henri's for an ice cream cone. At Friendly Henri's, you select a flavor of ice cream. Whoever takes your order packs the cone full of ice cream. They then add a generous hemisphere or half sphere of ice cream on top. Friendly Henri claims, oh, oui, the amount of ice cream inside the cone is the same as the amount of ice cream outside the cone, or your money back, madame. However, Friendly Henri refuses to say how tall the cones are. This is his secret. Fortunately, you and your team are able to determine the information shown in the figure above. Okay, so forgive my terrible French accent. I thought I'd put it in there for a little bit of entertainment. Sorry if you found that difficult to sit through. So here's my question. Can you tell me how tall this cone is given the information you have? Okay, so we know that he's telling us that he's going to fill the cone and then he's going to put a hemisphere or half sphere of ice cream on top. He tells us that the amount of ice cream on top is the same as the amount of ice cream in the cone, but he won't tell us the cone height. So please pause the video, either find the height and explain how you found it, or explain why you can't find the height of the cone, and then when you're ready, unpause, and you can see what I got. All right, so you actually can find the height of the cone, and it just requires you to have access to essentially two formulas. The first is the volume of a sphere. The volume of a sphere is equal to 4/3 times pi times the radius cubed. Now this is a hemisphere, so this is half of a sphere. So what we need to do is we need to turn this into, instead of 4/3, 2/3 pi r cubed, because it's half of this. Okay, then we have the volume of a cone, and that is 1/3 pi r squared height. In other words, a third of a cylinder with the same base and height. All right, so what we're told is that essentially 2/3 pi r cubed must be equal to 1/3 pi r squared height, or my money back, right? What I'm saying is the volume of the hemisphere, the stuff you can get in there, is equal to the volume of the cone. Okay, so now what I'm going to do is do a little math here. So first the pi's will cancel. Then 2 of these r's will cancel with 2 of those r's. And then I'm going to multiply through by 3. So I have 2r is equal to h. And now I know that r, because 8 is equal to the diameter, r is equal to 4, so h is equal to 2 times 4, which means that 8 is equal to h. Plugging back in, if I do 2/3 pi r cubed, so if I do 2/3 times pi times 4 cubed, I get about 134.04. And if I do 1/3 times pi times 4 squared times 8, I get the exact same thing. So I can confirm that when I plug in, and it's actually the same down to every single digit on my calculator, which confirms that the cone volume and the hemisphere volume is exactly the same. So hopefully you're able to get this right. If so, congratulations. This is just an application of volume. Please make sure you check out the check-in on volume today and surface area so that we can be in a great position to go into our final assessment. Best of luck, folks. Don't forget to love math, and remember, you can do it.